This conference will now be recorded.
Okay, so, in the last class, we were talking about the exposure at default and how to prepare the data at exposure at default. So one of the important things that we saw was that the target variable that we were trying for which we were trying to develop the model, right? So that target variable was the credit conversion factor. Now the credit conversion factor was nothing but that credit conversion factor was aiming at is aimed at converting the on balance sheet into the off balance sheet balances to an equivalent of the on balance sheet, right? And that credit conversion factor actually shows the rate at which an undrawn credit can be drawn, or the rate at which it can be drawn. So the rate at which an off balance sheet item can become an on balance sheet item. So how is it that what is the rate at which an on off balance sheet item can become an on balance sheet item? So that is the rate at which they were looking, right? Now, one of the so the question, so the CCF was the target variable, and one thing that we saw is that the entire process of the data design, right? Right. So while we were choosing the data, when talking about the entire part of the data design, it was designed such that there was no volatility or no unnecessary fluctuation in the target variable, in the CCF variable. So, this is something that we first of all need to understand, right? So this is something that we need to talk about. This is something that we need to fine. So now one of the most important question over it. So so that was the so basically while we talk about the EAD data, the exposure default data design, we kind of divided like this. So we the entire design is structured such that the no volatility is created, right? Now, so no volatility is created in the overall data structure. Now, what happens over here is the following. So over here, before we move on, right? Before we move to talk about, the LGD model data design. So let us very quickly create a kind of a flowchart, or let's kind of create a summary of all the points that we had that discussed, right? So basically, the entire discussion begins from the point that the target variable that we had. So the target variable that we have over here is the CCF. So for the credit card products, the target variable is the credit conversion factor. Now the first question that comes out over here is, so the first question it talks about over here is that whether is it you know so like, so is the headroom low or is the headroom sufficiently high? So over here, the first question that comes out over here is in terms of headroom. So when I talk about a headroom, what it means is, when I say high headroom, what it means is that the balance is not very close to the limit. And over here, when I say headroom is low, the headroom is low. So when I say the headroom is high, or when I say the headroom is low, so these two pertain to the two alternate definitions of, uh, you know, so it pertains to the two alternate definitions of the CCF, right? Now, if the headroom is relatively low, then the second definition of CCF is to be used. Then, which is that definition that we are using? We are using the definition or basis the CCF2, which is, or the denominator of which we do not have the headroom, but rather we have limit. So it is called, I'm writing this in short. So this is additional drawings prior to default. So I put it as PGD, that is prior to default divided by the credit limit. Produced. Right. So we have the CCF2, which is the additional drawing prior to default divided by the credit limit. And if the headroom is high, then we are using the first definition of default, which is the CCF1, or the original definition, which we say additional drawings prior to default divided by the headroom. So this is the additional drawing prior to default divided by the headroom. Right. So this is how the this is what the definition was. Now, when I talk about this additional drawing prior to default, so there are 2 points which again comes into this. So there are two components which can also add to the volatility. I mean, which can add to the volatility of the CCF. Now, while we talk about this headroom, high headroom and low headroom, so the first question was one of the most important questions which we tried identifying over here is identifying the cutoff, the headroom cutoff. Find the cutoff. So identifying the cutoff, that is the headroom cutoff. Right. So identifying the cutoff value of the headroom which is there. So that is one of the first analysis, right? So now the question is that how do we identify the volatility, which we have already discussed. That we identify the volatility by looking first by dividing the utilization into bands or the headroom into bands, and then checking that corresponding and calculating the respective CCF, looking into the distribution of the mean of the CCF and the standard deviation, and see what is that point from where the standard deviation suddenly jumps off in the CCF. So you know that once you hit that headroom band, your CCF has become volatile. So that's one of the checks, right? So that's the headroom check. Now, when I look into the additional drawings by the additional drawings prior to default, so there are two components to this. So obviously, one of the component that we have is the exposure at default, or the total exposure at the time when the account has defaulted. And the second that we have over here is the component which is the balance component. Right now, balance is something which we need to identify. So EAD minus the balance is your additional drawing because we are looking into the additional drawings which has been done before the account has gone into default. So when I talk about this particular balance, so there are two parts as we had observed in the last discussion, that once we have the line increase which needs to be taken care of. So basically, we need to identify whether there has been a typical line increase or not. And if there is a line increase, then that needs to be documented. And so basically, the line increase, then the line increase indicator has to be calculated, and then it has to be the balance has to be kind of, although the exposure has to be kind of calibrated to the point as if there was a no line increase, right? So what if there was no line increase exposure value, right? So that is something that we have. The next that we have over here is the line increase, and the second that we have is the material balance. So if the balance is an immaterial balance, so when you're looking into you are to analyze this, so this is something that we need to take into account whether the balances are immaterial. Otherwise, if that is not the case, then in the case of an immaterial balance, there can be if the balance is absolutely very small, then what we say is that the balances would kind of keep on going down. So they would kind of fluctuate, and it would be a very low intensity figure, right? So your line increase and your immateriality is, so immaterial balance is something which you need to take care of. Okay, fine. Okay, so we have line increase and we have the immaterial balances. The immaterial balances. Now, when I talk about this immaterial balance and stuff, so over here the question that comes out is how we to identify the line increase. So obviously there is a line increase indicator, as I had discussed. We have a limit increase indicator, and every account and every bank has a different way of treating their accounts. If their account is actually undergoing an upgrade, so you have an upgrade, and you know that there is a certain flow. You know that there is a certain thing be taken care of. So I mean, if the limit increases, right? So every bank has their own accounting process, and from that process, once you know that process, report that, and from there you can identify a limit indicator. way generally it happens for some of the banks is that when your account I mean you go and upgrade, right? So so once your limit is increased, right? So from one point to another point, you are generally treated as a separate account in that, and your account number undergoes a change, and a certain flag or a certain indicator value or an indicator value is created corresponding to that. So let's say update, right, or upgrade or something like that. An upgrade variable is created. So from that upgrade variable, you can actually create the limit increase in the flag. So it comes out that way, right? So this is something that we would want to. So this is something that we would kind of try to understand. Is something that we would kind of try to look into. So this is one case, right? So the next case that we have over here is so obviously line needs to be identified and it needs to be taken into account when the data is being prepared, because this will help us prepare the target variable. Now the base data for the EAD is clear. We know it is a subpart of the PD data. So accounts which are like which are existent there, I mean active there on the snapshot, but have defaulted in the performance from your EAD base. And once you do that EAD base, you create the CCF, when the model is being developed, right? Okay. Okay. So these are some of the important questions that we have already talked about. Okay. So now another important question that comes out over here is that if I am to work with this particular model, right? I need to have I need to know what are the exclusion that needs to be performed, right? So EAD exclusions. So obviously we have had seen a set of PD exclusions. So over here, what we are going to do is we are going to talk about the EAD exclusions. So the EAD exclusions are placed under three broad heads. Now, some of these exclusions will also be a part of the PD exclusion, but there will be some exclusions which are a part of, so which will also be within the EAD, because given that these were snapshot exclusions, it will be snapshot exclusions. The exclusions for both PD and EAD will be the same set of exclusions. exclusion that we have over here, right? We need to have an understanding of now, as I was saying, these exclusions would be something similar to what the PD exclusions are, because the set of accounts that EAD and PD has are similar set of accounts, right? So what are the exclusions? So the exclusions are divided into three broad types. So the first set of exclusions are the regular set of exclusions or the standard exclusions. These are the standard exclusions. What are the so what are the standard exclusions that we will kind of face over here? So obviously, because it's a retail portfolio, so all kind of corporate QRRE or commercial QRRE product, commercial revolving products need to be removed, right? So let's say like corp cards. So if there are corporate cards, they need to be removed. Corp cards, right? So then they'll have cards like discontinued cards. So cards which has been, let's say, discontinued. Let's say they, as on snapshot there is an account which has who has kind of closed their cards or kind of said that okay, I'll not be using my credit card anymore. So they are the discontinued cards. So these are to be used. Now a discontinued card example is, or a discontinued card is, or discontinuity example exclusion is eligible for card only. This is not kind of eligible for personal loans. So there are call cards, there are discontinued cards. The third that I have over here will be the frauds. That is operational frauds, not credit frauds. So frauds. And when I say frauds, I say it is operational frauds. Operational frauds. Then there are cards which are deceased, and a very special type of a card is for a zero limit. That's also there is a deceased exam exclusion. If an account is deceased as of the semester, then it is removed, right? So, however, the recent PRAs or the PRA definitions also include this as a bad definition. This is the case you do not exclude those records, right? So, and there is zero limit card. Let's say, for example, a card has been blocked, right, and its limit has been reduced to zero. So you have a zero limit card. So if you have these kind of features or any other similar features, let's say blocked card or card which has been blocked, etc., are something which we blocked as in depending on the obvious blocked indicator. Let's say it has been discontinued, so the card has been blocked, and so on. So in such a case, those are something which we would the things that is The next set of exclusion that we have over here are, yeah, so there was fraud, disease, and right. So these exclusions you will see are also very similar to the PD exclusions, and the reason that they are kind of in line with the PD exclusion is because the EAD exclusion, the snapshot EAD data is the same as the PD snapshot. So those accounts that I'm selecting from PD for EAD accounts are those accounts which has been active on the books of the bank, and from there I am selecting the EAD. So the EAD accounts are kind of very much there. Okay. Now, from there are a few important observations that you can make. Yeah, so there are some of the few important observations that you can make is that given that the base of the observation at observation the base of the accounts are similar, right? So therefore, given that the base of the accounts are similar, so therefore, uh, the exclusions that are applicable to the right. So that's pretty understandable. Now, from there, from the standard exclusions, there are a set of certain existing exclusions. So, if an account has already defaulted as on a given snapshot, so let's say there is some existing defaults. So, any existing defaults will not be included in the model development of the EAD data. Existing defaults. So, any of the cases which satisfies the existing defaults will not be incorporated here. So say loan restructures, LRDs. Write-offs, charge-offs, there is so these are the two important exclusions. And obviously, there is one also another important thing is that if there is a fraud or a bankruptcy, I mean operational fraud, if there is operational fraud or an operational bankruptcy in performance, then it is to be right. So these are the records which are to be excluded. Right? So when we have the data, so these are mostly done when we get data. From there, you extract the default base, you get it, and you, if it's a QR, when it's a QRR, you create the CCF figure, right? And once you have the CCF figure, the next step will be the model development step, right? So over here, this framework that we are going to use is we are going to use the decision tree framework, and we're going to kind of split the data into different segments of homogeneous groups of loans, and we are going to test how that model is to be validated, developed, validated, and monitored. Okay. So these are this is some so this is the model of your typical model for QRRE data, right? Now, now one thing you can see is that the PD model and the EAD model that we are talking about, they flow together, right? Now, this is one main reason as to why you would see that many variables or like many uh, many developers, right? So people who develop the PD model also develop the EAD model, right? And LGD model is generally developed separately for people. And people who are developing LGD model, within them, they are a specialization because LGD model is something which is so LGD model is something which will kind of give them a so LGD model is a separate specialization altogether, right? And you would see people who have been developing LGD model continue developing LGD model for a long period of time because it's very difficult to know people who know the exact art of developing an LGD model. So PT and EAD are pretty, I would not say simple, but they are more conventionally developed because one of the major challenges that you face with any LGD model is that LGD models have a recovery, right? It has a whole recovery concept associated with it, which is a whole set of data, and that data adds on to the challenge of the model. Then there are different characteristics, there are issues, there are recovery processes, right? So there is a whole set of information which comes into play. So, those make that LGD model a very complicated model, right? The next model design that we're going to talk about is the LGD model or the loss given default model. So we have already talked about what a loss given default is, what are the characteristics, and over there we saw that for LGD, EAD plays a very critical exposure, play a very critical role, right? And we'll see that for a QRRE product, and EAD is identified as a CCF, right? So having said having said, so now the first thing, so there are a few things that we need to do before we structure out the development of the LGD model. Okay. Okay. So as I was saying, talking about loss given default. So first of all, let us define the loss given default. Or as I talk about LGD, so one very important thing that you need to understand is that LGD talks about economic loss, not accounting loss. So it talks about an economic loss, not an accounting loss. In an account, it's not an accounting loss. So if it had been an accounting loss, what would have happened? If it was an accounting loss, then people would have directly computed the just seen how much it has recovered, and what the total loss which is gone in, and then they subtracted it, and that's the loss. But that recovery has a dimension to it. So, the recovery process happens over a period of time. And given that it happens over a period of time, so therefore the issue that happens is there has to be a discounting factor because you are trying to capture the observed losses, right? And so you're trying to cover the observed losses and not, I mean, you're trying to capture the economic loss and not just the accounting loss. Right. So this is the basic of this is what the basics of your loss given default is. Okay. So now the question is, is the net present value. This is something that we are. So this is something that needs to be taken into. Now the question that comes out is that how do I calculate this LGD, or what exactly will be the formula for computing this LGD? So what are the components? Because this formula, the formula that we use for computing LGD, also give me the components of the LGD. So the first, what is it that you need to take into account when you are kind of talking about LGD? The first is principal loss. Now, when I say the principal loss, the term principal is more relevant towards your loans product, right? But when I say principal loss, I mean loss of balance in a credit card product. That's the principal loss. Now, now to this we adjust the recoveries. But the recoveries happen over a period of time. So therefore, this is the discounted values of the recoveries that we are talking about. So we need to take into account the discounted values of the recovery. The discounted values of the recoveries. Plus, what I say is the discounted cost of discounted cost of recovery divided by the exposure at the exposure. Right. Right. So this principal loss that I'm talking about over here is now again nothing but your nothing but your EAD. The EAD minus the discounted value of the recovery plus the cost of recovery that has been incurred. So that becomes your LGD. Now over here, the most important part is that about the exposure at default, you have an idea. You know what is the exposure at default. You have you have the observed figures of the exposure at default from the you have the CCF, and from there you can actually calculate your exposure at default for the revolving product. Right. Now, now next two things are to assess the cost of the recoveries and to assess the discount values of the recoveries and the channels through which the recovery is done. So how is it that the recovery is done? That becomes a very important factor. Now, for unsecured credit product, this part is not really very important, right? Because over here you don't have any collaterals, and hence kind of selling of the products or trying to yeah. So that's where kind of trying to sell the products or having any such thing that does not impact that, because this is unsecured, you're just trying to recover whatever you can. Okay. Now, one very important thing that we need to understand over here is that it is this part which which makes the LG model totally different from all the other models. It is this recovery portion, right? So the question that comes out over here is that I would not be working with EAD because I've seen what this exposure at default is, right? Now, so I've predicted or I've seen how to calculate this exposure at default. But to calculate this LGD, it is this recovery rate that I need to capture, the net recovery rate that I need to capture over here. Or as we would want to identify over here is the expected by EAD. Right, by EAD. Now, given that this net recovery by EAD is calculated here, therefore, this is called the recovery rate or the recovery rate. Recovery rate. So 1 minus this recovery rate is your LG. So obviously, one of the ways to predict this recovery or to predict this incident is to capture the recovery rate or to estimate the recovery. Now, when I'm trying to estimate this recovery rate, it is not always possible for me to find out. But one thing that becomes important over here is that I don't know what the recovery rate is. So when I'm trying to predict, all I can predict is the expected recovery rate. What is this expected recovery rate that we are talking about? The expected recovery rate is nothing but the recovery rate at time t or at that month relative to the historical recovery rate at t divided by historical recovery rate. The historical recovery. Now, if I am kind of adjusting this recovery rate with the historical recovery rate, What am I essentially doing? I am kind of taking into account the fluctuation which has happened across business cycles. So if I'm doing it by the historical recovery rate, what it essentially means is I'm kind of adjusting for the effects of the fluctuations, right? So 1 minus the expected recovery rate is the LGD, right? So once I have my discounted values of recovery, once I have my discounted costs of recovery, I can easily calculate this expected recovery rate, right? And then 1 minus that LGD will be the observed LGD figure, right? Now, this dividing by the historical recovery rate is another way. So, is again another way to reduce fluctuations in the LGD figure, like you did for the EAD figure. So, when you are dividing it by the historical recovery rate, you are kind of smoothing it down so that the LGD also does not fluctuate too much. Because whenever there are downturns or whenever the recovery rates have fallen, the LGD will tend to spike up. So one very important thing is that LGD does not really spike. Okay. So one minus the expected recovery is the so in this model, I'll have the observed values of the recoveries, and therefore one minus the recovery rate will be observed, and the observed LGD itself is the target variable in my model, right? Because I know what the recoveries are, I know the recovery costs are, therefore that and at 1 minus doing that is the right. So LGD or the observed LGD is the target value. And you would observe that this observed LGD is the target value and it is a fractional value. So this is the target value. Target. Now, what are the other conclusions to which we can come to from here? So obviously, this is a target variable. This target variable lies between 0 and 1. And given that this target variable lies between 0 and 1, I need to, and if I'm using this target variable to develop my model, I need to ensure that this one is free from fluctuation so that no unnecessary fluctuation in the series, free from unusual fluctuations. From unusual change. Free from unusual change. So I have this target value. Right. Now to ensure that it is free from unusual changes, what I've done over here is we have set that find So what we have said is that fine, we'll divide it with the external date to get the expected period and not the expected date will be the observed LGD. Right? Now the question is how to model this, or the question that comes out over here is how to design the model or how to design data for this LGD. How to design the LGD data. So how to design the LGD model data. Mhm. The question that next comes out over here is that how to model this loss given. Right. So how to design. Okay, so how to design the LGD data. Now this is an important. So I'll just take a couple of minutes break and then we'll get started. Just give me 2 minutes.
This conference will now be recorded.
Okay. So when I talk about the LGD data, right? So we have already said that that you know so we already said that there are two types of LGD data models that we generally need to build. One of them is that those accounts which have already defaulted as on snapshots, right? And the second set of models are for those accounts who have not who are active as on the performance, but are defaulting, I mean, which are active as on the snapshot, but are defaulting on the performance, right? So let's say there is a set of accounts which is standing as on, let's say, 2010, or let's use an example. So let's say there are some accounts which where we are standing on 2017-06, right? Now, as on 2017-06, so as on 2017-06 is the snapshot. So there will be two sets of accounts which are there. So there are some accounts, right? So 2017-06 will have some accounts which have already defaulted as on snapshot. Now these accounts have already been excluded under the while preparing data. Therefore, these accounts are not reflected in the EAD data. So default on snapshot. So default on snapshot. Now this set of the records are the ones which has already been excluded as a part of the EAD, PD and the EAD model. Right. So the remaining is, and this base is mutually exclusive with those accounts which will be the performance defaults. Are performance defaults. The second is the performance default, right? So these are, so so therefore the LGD models will be of two types. One will be an LGDA for non-defaults. So the first set of models will be LGDA for non-default. So accounts which are defaulting in the performance. And the second will be LGDB for defaults or accounts for defaults. So for defaults. So we are going to build these two type models. Now observe one thing, that as I talk about the discounted factor of recovery, I'm talking about the discounted cost of recovery. So one of the most important questions that comes out is that when I talk about this discounted values of the recovery and cost, the first thing that I need to actually capture over here is cumulative recovery. Right. So over here, while we talk about LGD and all these things, a very important, one very important functionality which we need to take care over here is calculate the cumulative recovery. Okay, we want to find out the cumulative recovery. Right. So over here we have the cumulative recovery. Now the question that comes out over here is how do I estimate this cumulative recovery, which is nothing but the chain ladder approach. So the next point that we need to talk about over here is two things: the model data design that the client is or the that that the modeler does, right? The sets of the data preparation and how to prepare the data to find that data. That is another one important. So we have the chain ladder approach over here. The chain ladder approach. So the cumulative recovery or this chain ladder approach helps us estimate the cumulative recovery or the expected cumulative recovery for incomplete workout processes. So when the recovery has not been totally completed, right? Then the chain ladder approach is used to extrapolate that recovery, and then that recovery, the cumulative recovery, is then discounted using the interest rate, right? So the next question, so there are two questions next. Number one is that when we are developing the data for LGDA and LGDB, how does that data look like, right? And the second that we talk about over here is that when I'm trying to uh, kind of so how is the data impact, right? And then when I'm trying to calculate the cumulative recovery, right? How is it that the chain ladder approach helps me calculate the cumulative recovery? And once I have the cumulative recovery, I'll get the cumulative cost. So subtracting them to relative to the historical recovery rate, I'll get my expected recovery rate. Right. So now now the two things over here is that LGD is number one, the target variable. Number two, it's called the fixed horizon method. The fixed horizon method. And then the second is the cohort method. Now these are the two methods that we need to talk about. The fixed horizon method and the cohort method. right? So these are respectively used for quantifying the LGD of a data preparation, respectively for LGD A and the LGD models, right? So the question comes over here is to understand what exactly the chain ladder method, how does the chain ladder method operate in calculating the cumulative recoveries and recovery costs? And the second question that we ask over here is that how is it that the fixed horizon method and the co-op method us in help us in designing the data for the right. So these are the next two portions that we discuss in our next class. So tomorrow we will finish the LGD model design, and Saturday Sunday we do model development, and with that we close the URRE Basel model development. So over here the next part is to talk about the model design and then the segmentation framework, monitoring and so before tomorrow's session, just try to go through this recording and the EAD model design. So we'll read tomorrow too. Thanks, sir.